Courses in the cement industry. Present to you. Friends of the Courses in the Cement Industry channel. In this video we will explain, and watch the video from site. Steps to replace rotary kiln shell sections. The shell is the driving force behind many of the problems that arise in a rotary kiln, and these problems are typically caused by what are commonly referred to as doglegs, red spots, and hot spots. Sometimes red spots and hot spots are the root cause of a dogleg, and other times they are not. Shell irregularities, be it out of roundness, or a crack in the shell, precipitate a wide variety of issues. All of these issues have detrimental effects on the ancillary equipment. They range from cyclically loading rolls and frames causing hot bearings or frame failures, wobble in tires leading to convex tires, and concave rolls resulting in difficult thrust adjustments, and variations in drive loading causing poor gear set contact, and other drive equipment issues. Course of action. Once a shell anomaly is discovered, the course of action is the same. How much shell is needed and where? First, someone with experience in rotary kiln repair should be consulted, and all of the problems identified. From there, a rotary kiln shell run-out analysis will need to be performed. This shell run-out analysis will provide the information to determine which portion of rotary kiln shell should be targeted to remove the detrimental dogleg nodes and shell deformation. With this determined, the rotary kiln shell can be manufactured. New shell options include machine tire sections, uniform thickness free-floating tire pads to allow for future tire gap control, upgraded tire retainer designs using improved welding procedures, and tighter rolling tolerances for better quality refractory installations. After all, what point is there in replacing shell if you are not going to improve longevity and reliability? The rotary kiln shell replacement process can be broken down into the following steps: layout, removal, installation, alignment, and welding. 1. Shell layout. The layout of the rotary kiln shell to be removed is a critical step, as it determines the amount of shell to come out, in what sequence and in what sizes. In this step, everything from crane capacity and shell section weights and lengths to cribbing locations and section staging is taken into account. Everything must be properly placed so that the next step, shell removal, goes seamlessly. Once the rotary kiln shell lengths, weights, cribbing, and crane requirements are determined, the shell layout can begin. The ultimate goal is to cut the shell at the proper location, perpendicular to the center line of the rotary kiln. One of the best ways to do this is to perform a series of stop cuts in the rotary kiln as it is rotating, paying special attention to keep the thrust tire against the thrust roller, and also against the same set of tire retainers. Once the cuts determining the overall length are complete, a relief cut must be laid out. This is usually 10 to 12 inch wide section on one end, and once removed, will provide some extra room for removing the shell. Finally, the rotary kiln must be parked and the drive locked out, the support cribbing raised into position, the relief section cut out by hand, and the rotary kiln pushed apart by 1 to 1.5 inch to allow extra room to get the new shell back in. 2. Shell removal. With stop cuts in, the cribbing up, and the relief section removed, it is time to rig the shell pieces for removal. Typically, a spreader beam is used to provide more leeway and control while removing a section. Under the spreader beam, braided cables can be shackled together through the clearance holes that have been cut in the rotary kiln and reinforced. It is critical that the shell thickness is analyzed to make sure that the cables and reinforcing will not tear the shell. The shell is then cut free of the rest of the rotary kiln. With the use of torches, 2 readings are taken, one at the uphill run-out stand, and one at the downhill. The resulting numbers are then taken and laid out on a polar graph. When looking at the magnitude of the runout on a polar graph, opposite readings will show any corresponding moves. Several of these indications in the same quadrant will warrant a corrective adjustment of the joint. With runout readings showing no corrective adjustment, the shell and joints are ready for the next step, welding. This process will be repeated until all of the shell sections have been removed. The final step is to grind the exposed ends of the shell. Since the new joints were cut with a torch, the cutting slag and imperfections need to be ground smooth, to provide a good surface to weld. 3. Installation and alignment. The installation of the new rotary kiln shell typically occurs in the opposite order of the removal. The shell sections are hoisted, ensuring that they are hanging perfectly on the rotary kiln slope. Once in location, this will provide an even joint to fit. Consideration should also be given to installing the longitudinal seams in adjacent shell sections opposite each other. The rotary kiln shell is held in place by temporary joint hardware and cribbing as required. The joint hardware typically consists of angles and radial adjustment blocks, welded to the shell and threaded through rods and nuts that fit through the angles to adjust and support the shell. Radial shell mismatch is extremely important when fitting the shell using the radial adjustment blocks that were installed in the shell. When new shell fits to new shell, the inside diameter is typically the same, thus there should be less than a 1/16 in mismatch. However, it is not uncommon that the inside of the old shell is corroded. We follow together installation and alignment. When this is the case, it is important to ensure the mismatch is very even around the joint, and does not vary by more than 1/16 inch, even if the total mismatch is 1/8 inch. With the joints aligned, the through rods are used to pull the shell sections together. Tie bars should be installed to lock in the joint alignment attained with the joint hardware and to take up the torsional forces exerted on the joint during rotation. At this point, all equipment and material is removed from the inside of the rotary kiln. Run-out stands, fixed location roughly 12 inch, uphill and downhill of each joint are set up. The rotary kiln is rotated and a set of stations, 1/12 inch, laid out on the shell. At each of these stations 2 readings are taken, one at the uphill run-out stand, and one at the downhill. The resulting numbers are then taken and laid out on a polar graph. When looking at the magnitude of the run-out on a polar graph, opposite readings will show any corresponding moves. Several of these indications in the same quadrant will warrant a corrective adjustment of the joint. With run-out readings showing no corrective adjustment, the shell and joints are ready for the next step, welding. 4. Welding. The shell is typically welded on the outside first. The shell joints are ground so that the mill scale is removed several inches uphill and downhill of the actual joint's bevel. A root pass in the base of the bevels is welded in by hand, with the welder taking care to properly preheat the shell. The remaining outside bevel is welded using the submerged arc welding (SAW) process. Submerged arc welding is the preferred welding method for the majority of the bevel because of its consistent, superior quality of weld and its very high deposition rate. With the outside bevel complete, the inside joint hardware is back gouged off, the spots that were welded being ground smooth. The nose of the bevel along with the seal pass is then removed via back gouging. From there, the welders weld up the back gouged inside portion of the joint, and the shell installation is basically complete. Tires can then be aligned and retainers welded. Once finished, the gear can be aligned if required. This simple procedure, when carried out completely and properly, will yield the desired result of a once again straight rotary kiln. The replace rotary kiln shell sections process can be summarized in several steps. Step 1. Before starting to work in the rotary kiln, safety locks must be implemented complying with the lockout and tag-out procedures established in your plant. Step 2. Depending on where the damaged section of the rotary kiln is located, remove the bricks or chains etc. and perform a thorough cleaning. Step 3. Appropriate scaffolding should be erected with external work platforms around the affected area and inside the rotary kiln shell. Step 4. Manufacture 2 spider supports, and weld into the existing rotary kiln approximately 1 meter, from the joints of the replacement section. Angular sections of 75 mm by 75 mm by 10 mm welded, to a diameter of 400 mm. Central disc is recommended. Spiders are installed to maintain cylindrical dimensions during repair. Step 5. A similar structure is recommended at each end, and within the center of the new replacement rotary kiln section. During the complete repair, the rotary kiln must be turned manually, as necessary to help the convenient positioning of the weld. More than 4.2 meter rotary kiln, equal 8 spokes. 4.8 meter rotary kiln, equal 10 spokes. Step 6. The weight of the rotary kiln must be supported by hydraulic jacks, mounted on wooden sleepers, or steel support structures manufactured, on each side of the replacement area, and located under the spider reinforcements. Step 7. Carefully mark the precise reference points around the rotary kiln on the cutting line. Place Bugo's magnetic track around the circumference of the rotary kiln, and secure it with clamps. Make sure the cutting head follows the reference marks. Step 8. The first cut must be 150 mm, within the required length around the circumference, leaving 4 sections intact, approximately 300 mm, wide at 12, 3, 6, and 9 on a clock face. Step 9. Re-establish the track, and recut the circumference on the actual length cut line. This will leave 4 150 mm sections uncut. Step 10. Rotate the cutting head at 38° angle, and repeat the process on the true cut line. This will affect a chamfer that leaves a rounded tip, 2 mm wide. Leave the 4 sections uncut, as with the previous cuts. Perform the cutting process in this way, at the other end of the damaged section, to leave a true measure for the prefabricated rotary kiln cylinder. See this video. Another method for the cutting process, at rotary kiln shell section. Step 11. While the rotary kiln is still intact in this way, a series of supports, brackets, for the extraction bolts must be welded in place. Two main versions of the screw extraction brackets are used. Some vendors recommend an angle cove design, while other rotary kiln suppliers prefer a U-shaped format. Both are suitable and can be seen in these photographs. They are evenly welded around the interior of the existing rotary kiln, at both ends, and are approximately 400 mm apart. Step 12. With the crane in position, the 4 areas at each end can be cut, and the damaged part of the rotary kiln can be removed. Profile the same 38° angle to these sections, as recommended above. The damaged section of the rotary kiln is supported by a mobile crane, which must be able to lift the total weight of the component. See this video. Step 13. Lift the new section of the rotary kiln, and place it in line. This cylinder is also prepared with a front angle of 38°. In alignment, it may be necessary to trim again for a good fit up. When positioned, the welding joint will be at an included angle of 68°, preparing a single V shape with a 2 mm rounded tip on both sides. Step 14. Verify the alignment and fully weld along one side, a series of approximately 15 strong backs along the two joints. Step 15. Weld the extraction bolt brackets to the new section to align with the previously welded parts. Insert fully threaded 30 mm thread screws into the joint, and secure 4 hexagonal nuts per unit, 2 outside and 2 inside the bracket, to create a push and pull mechanism. Weld in place a series of approximately 30 screw blocks spaced apart to the new section to cross the joint. Adjusted to align both cylinders. Step 16. Turn the rotary kiln manually to perform a true alignment check. As the rotary kiln rotates, 12 reference points are selected, and measured using a polar diagram, 1 meter away from each joint. This determines the true center line of the rotary kiln. If the test is unsatisfactory, strong reinforcements are released with grooves, and traction bolts are adjusted where necessary. Strong backs are re-welded, and an additional alignment check is performed, until the rotary kiln is within tolerance. Step 17. Before welding, preheating is critical. The correct preheating temperature has been previously calculated in this procedure. The ideal for this base material with its cross-section is 208 degrees C, although in the application it has been found that it is difficult to achieve due to the effects of the mass and the heat sink. Preheating of 128 degrees C, at a distance of 150 mm, from each side of the joint in practice has been satisfactory. Step 18. A thermal crayon, or preferably a pyrometer, will be used during welding, to ensure that this temperature is maintained. Reheat as necessary. Step 19. The recommended electrodes, please, reference to case study for the welding of replacement rotary kiln sections, should be preheated for 2 hours, at 208 degrees C, in a suitable baking oven. Remove 10 electrodes at a time, and transport them to the workplace in portable heated shakers. It is recommended that welding contractors are in possession of a current coded certificate, for EN 287 or ASME 9. These should be available for inspection if necessary. Step 20. Start welding from the outside of the rotary kiln, using 2 welders on each joint, that work continuously throughout the day. This will accelerate the downtime of the cement plant, and reduce reheating operations. Fully deposit a single pass root weld, using 3.2 mm electrodes. Observe the operator positioning sketch for welding. Remove bottom slag using an air chisel. Inspect for inclusions, if present, move and weld again. Step 21. Hot welding and intermediate welding can be completed in stages to fill 2/3 radius of the welding preparation. To obtain optimum mechanical strength, weaving should be avoided. Therefore, use reinforcement cords up to a deposit width of twice the electrode diameter. Return to the inside of the rotary kiln, and remove it with gouged screw blocks, strong backs and spider stands. Grind these gouged areas flush. Step 22. Using carbon electrodes 8 mm in diameter, and the air arc gouging process, perform an internal root preparation by inserting the outer root, weld again at a depth of approximately 10 to 15 mm, depending on the shell thickness. This will also eliminate any possible slag inclusion. Grind in the form of U-shape, to remove all waste from gouging. Be sure to maintain preheating, and deposit an internal root weld, using 3.2 mm electrodes. Complete the hot pass and the last pass, with 4 mm electrodes. Grind the internal surface flush, as welds that are undermined, or undercut can have the effect of multiplying stress. Step 23. Return to the outside and complete the filling and capping weld deposits, ensuring stringer bead format using 4 mm or 5 mm electrodes. Wire brush inside and out and visually inspect completed welds. Suspicious areas should be investigated, using penetrating dyes or preferably ultrasonic tests. Weld is subject to a 100% radiography at the end. Gouge and weld again any defect. Step 24. Remove scaffolding and auxiliary equipment. Replace any internal brick or chain work that is necessary. Return to service. Step 25. The correct alignment of the rotary kiln may be necessary to obtain an optimum service life of both the mechanical components and the refractory. Excessive loads should not be transferred throughout the rotary kiln. When finished, the best way is a hot alignment. A shell map can be supplied. Whenever this is done with the rotary kiln running in normal conditions, it will show the actual position of execution on the shell map. Watch this complete video of the process of changing a section in a rotary kiln. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.